So thank you everyone for joining us this afternoon for Bio Crop Connect. Just without further ado, we'll just jump right on it. So I'm mainly going to be talking to you about manure, just to keep with the topic of the day. Here I want to highlight the significance or importance of dairy and why we have this issue in the state, which is also an opportunity. But it is a tremendous economic engine for the state, the dairy businesses. So as you can see there, the numbers, 15.2 billion, 2022 estimates, almost 50,000 jobs. And that's just some direct dairy farm income, on-farm income. But then you add cheese production, which accounts for 90% of the milk production in the state, goes into cheese. That adds additional value of 37 billion to the state economy per year and more jobs. However, the number of dairy farms has actually decreased. I think we've all seen this in the news, how the number of farms have been decreasing in the state. But the total milk production has increased, so that shows, I guess, perhaps some efficiencies in the system. One estimate I found was from 2017 to 2022 or 2023, there was a 6% increase in milk production, even though number of farms went down. So with all this milk production and all this activity, obviously comes what comes out of the other end of the cows. And we have about 1.3 million cows in the state. So if you look at about how much manure a cow produces a day, and kind of try to figure out how much manure you might have per day, gallons of manure, you can see that is a significant amount. Kevin presented similar numbers too. So there are certain considerations. It's a big thing we have to handle. Like Kevin repeated there, you know, with great volumes of manure comes great responsibility as far as we manage this. So if we look at that manure and try to think about the farm level, you know, what does that mean? So there is a really cool database out of the University of Minnesota called the Manure DB. And so there's all kinds of information in there. The link is at the bottom of the slide, as you can see there. But you looking at data for Wisconsin only for the last 4 years, not including 2025, the average reported phosphorus content was about 7 pounds per 1,000 gallons as P2O5. So if you're doing an application of 10,000 gallons per acre, which might be a little moderate, I guess, if you will, compared to some other rates that I've heard people apply, but let's use 10,000 because it makes easier math, I suppose. Good for my brain. That will be about 70 pounds of P2O5 per acre that you would be applying with that manure application. So to put it in context, I put there on the second bullet what's the current corn grain production nutrient recommendations. And it's for a soil that ranks optimum level, and you're looking, let's say, at a yield goal of about 200 bushels per acre. It's about 70 pounds of P2O5. So it kind of matches, right? You're putting about the same amount that you need, but a couple of things to keep in mind is that because the liquid manure has a high moisture content, it's going to have, and you're applying it all at once, typically in the fall, it has a tendency to move readily under some conditions. The other thing is that often we also apply phosphorus in other forms, additional fertilizers such as starter and all that too. So typical applications are greater than that. And again, keep in mind that I'm using a 10,000 gallon per acre. So if you're applying more, obviously we're going to be exceeding that recommendation at the optimum level. And with this, it comes water quality issues. So phosphorus in surface water creates it can lead to algae blooms and hypoxia in the water. It can lead to fish kills. It reduces the value recreationally for those water bodies, which is another important economic engine for a lot of smaller towns in the state. In Wisconsin, by far, the total P, it's one of the most causes of impairment in the state. I think it's about 50% of streams that are impaired. It's because of total phosphorus. Lakes, it's a little bit less, but close to 40%. So it is a significant problem. Is agriculture the only source? No, but it's a significant source, if you will, to this phosphorus loading. And going beyond the state, there's also impacts looking at the Gulf of Mexico and looking at fluxes of phosphorus from the Midwest. So what I'm going to share with you a little bit to talk about the management related to cover crop and manure injection, as Dan introduced me, talked about. So this is going to be a compilation of data from different studies, which we use a rainfall simulator to collect this data. All of it was under corn silage production. We had with and without winter rye as a cover crop, and then we also looked at different manure application approaches, which I'll get to in a second. You can see a picture here of the rainfall simulator. You see that Ford tractor, that blue Ford tractor behind it. You have the tent that basically is a tower, is about 10 feet tall or so, high enough so the raindrops in the nozzle inside approach terminal velocity, similar to rainfall. This is what it looks like to the right. That's what it looks like inside the tent. So we install a frame that is about 3 feet by 3 feet, and then we can collect runoff from there using that hose that you see there that is under suction. And all of that then ends up going to collection vessel behind this orange, the Kubota tractor, where we can take samples and do analysis with those samples and so on and so forth. So all the data was collected in the same manner, applied the rainfall at the same rate as you see there on your screen, and the same total amount. So we collected these throughout different times of the year, as you'll see here in a second, to try to get an idea of the impact of the cover crop, but also the time effect of the manure application. So this table, what you're looking at is the compilation of those data, kind of a summary, looking at total and dissolved phosphorus losses for simulations done in October, April, and June, again, to capture those different times of the year. On the left column, as you see, we have the different management that we've been looking at. So the first word relates to the manure application method, so surface application, and this one had winter rye as a cover crop, deep injection with rye as a cover crop, LDI, it's low disturbance injection with the winter. Then the no MN is not a dig towards Minnesota, it's actually no manure with rye. So we're trying to use that as a control to see what's the effect of the rye by itself with no additional manure in there, and then a deep injection without the cover crop as a secondary control to compare. At the very last row, you see the p-value, so we're looking at statistical differences. So let's get started by looking at October. So all the simulations were conducted about 2 weeks after manure application. So keep that in context. So if we look at the total phosphorus, we see there with this NS, it's not significant. So there was no significant differences between the different managements that we were exploring here in the loss, and the values here are in pounds per acre. But we see, if you look at the p-value, that the p-value is relatively low. So we could say that there might be some numerical trends in here. And what we see here mainly is that numerically speaking, we see that there were greater losses with the surface application of the manure. We look at dissolved P, we see significant differences denoted there by that p-value of less than 0.001, with the greater losses again with the surface rye. So it sort of kind of follows that same trend on a significant difference between them, between the surface versus the other methods. So now we fast forward to April. So now we have a little bit more biomass out there. Things have happened, right? Winter happened, so we had other losses that we did not monitor, we did not measure, and we see that total P again similar. That p-value is 0.25. It's not significant, but now we see that the surface rye, if we look at just numerical differences at trends, the surface rye had lower losses compared to the other methods. So you may think, well, what happened here? So one of the most likely outcomes, or why this outcome is like this, is because we had greater losses during that period of time in the winter and earlier spring before we did the simulation with the surface method, or the surface approach. Dissolved P, you see that there's no significant differences. The p-value is quite high, so there's no numerical trends here, but you see that the magnitude, overall magnitude, actually dropped quite a bit by at least 1 order of magnitude compared to the October. And then fast forward to June, we see the total P again, same thing, 0.108, so 0.11 roughly. So not statistically significant, but very, very strong trends that we see here. And again, similar, we see kind of a scatter with the deep no cover crops, so perhaps maybe the disturbance affected, where on the other 4 you actually have some residue on the surface from the rye. And then the South P, no significant differences there. So what other things that we usually look at when we're looking at this is trying to look at load losses. Oh, and this is just an example of how that cover crop might look at different times of the year, and kind of the residue, what it might look like, just for visual reference. But we try to relate these losses to volume and sediment losses. And you can see that here. In the interest of time, I'm actually going to fast forward and show you in a graphical form here in a second. It's more compelling. So what we're looking at here is runoff volume on the x-axis versus sediment loss on the vertical axis. And you can see there's a pretty good consistent trend where as runoff volume increases, the amount of sediment loss increases as well. One thing we see is that as the runoff volume increases too, the uncertainty and the variability also increases. How about total phosphorus? Well, it follows that. Remember that the total phosphorus includes that phosphorus attached to the soil particles. So we see a very similar trend here with the total phosphorus losses. So in the context of cover crops and biomass, how about that biomass, right? We hear that there's all kinds of good benefits from it. So we see here that the winter rye biomass, as it increases, it reduces the amount of volume. So it's protecting that soil surface, and the roots also helping infiltration. And then also that results in reduced total phosphorus as well as we increase rye biomass. So we see that benefit. So what we see here is the time of the year of the runoff event is important. The application method, it's important. The injection methods resulting in lower losses risk compared to surface. The biomass of that rye cover crop was effective and it's helpful. And last but not least, stacking practices, management practices, is better than just trying to rely on a single practice. So some recommendation I guess we can draw from this and other information that we have been exposed to is that try to apply manure at times where there's low risk of runoff. I think Kevin talked a little bit about that. Keep the rates as low as feasible, inject or incorporate that manure. Plant residues, so now I'm extrapolating not just the cover crop, but they're very effective, but plant residues help reduce runoff, and so it helps reduce phosphorus losses. And also keep the necessary setbacks, as Kevin mentioned a second ago. So let's talk about maybe something a little bit different. Let's talk about the positive impacts of liquid dairy manure applications. So when we're looking at liquid dairy manure, I said there's phosphorus, but there's other things in there. So namely one of them, it's potassium, as you can see on that first bullet. So in a 10,000 gallon per acre liquid dairy manure application, as I mentioned earlier, you have about 180 pounds of K2O per acre, that you would be applying with that, and about 140 pounds of total nitrogen. And again, this is from that Manure DB, looking at those 4 years of data that I looked at. There's other good stuff. So there's essential nutrients for the crop, but there's also organic matter in that liquid manure. So 10,000 gallon application can supply about 1,300 pounds of total carbon per acre to the soil, which can be significant, as you will see here in a second in a table I'll share with you. Just as a comparison, let's get to the table. That's in the table. Corn stover produces about 10 tons to the acre, or 8,400 pounds of carbon to the acre. So let's look at a comparison of different inputs, I guess, if you will, to the soil of organic carbon. So on the top row, you see there, well, on the left column, we have the different sources. So dairy manure application compared to other inputs in agricultural system, corn stover, soybean stover, winter rye as a cover crop at 2 different biomass levels. And if we look at dairy manure, we see that about every 1,000 gallons can include 131 pounds of carbon. So if you assume a rate of application of 10,000 gallons per acre, that's a total of 1,300 pounds per acre of total carbon applied to the soil. The last column, it's going to be the relative contribution of this dairy manure application relative to these other inputs in agricultural systems, to soil systems, agricultural soils. So corn stover has about 42% carbon concentration. So if we assume a 200 per bushel acre production, that's about 8,400 pounds to the acre of carbon. So if you compare then now the dairy manure supplies about only 15-16% of what carbon stover would. However, let's compare it to something like soybean stover or soybean production. So 50% concentration of carbon in the stover, about 60 bushel per acre simulated yield here that we're using as an example. That contains about 2,100 pounds to the acre of carbon. So the dairy liquid manure is actually supplying 62%, almost of the same as the soybean stover. So how about cover crops? You know, we talk a lot about cover crops. So winter right here, assuming about 45% carbon concentration, and having something that has a decent amount of biomass, but not crazy amount of biomass, 2,000 pounds per acre, about a ton. That's can contain about 900 pounds to the acre. So that dairy manure application is actually contributing 144% of that winter rye. So a lot more, 44% more than that winter rye is. If we look now at a winter rye that is a little bit older, so that's why it has a little bit higher carbon content, so 4,000 pounds to the acre, more mature, that it's about 2,000 pounds to the acre of carbon. And so that dairy manure application at 10,000 gallons is about 65% of that winter rye biomass. So we see that this can be significant. The other question is, what's the turnover rate of the biomass or the organic matter in the soil, which can be just a fraction. Some materials might be anywhere like 10% of it converts into actual soil organic matter. So you know, it takes a lot of organic material to increase soil organic matter in time. But just wanted to put this in context, some of the positive impacts too of dairy manure in here. So with that, I guess I'm just going to leave it for questions in the chat box, if any, and leave you here with these closing remarks so you can read them at your leisure. Thank you.